The two main operations in calculus are the derivative and the integrals. The derivative measures the change over time, while the integral is the reverse. It's measuring the accumulation of quantity over time. The derivative is denoted by the tag. So if you have a function of t, then the derivative would be function tag f tag of t. It would actually measure the change that you had over this t. So if you say that you started from t1 and into t2, those are the two timestamps that you are looking at, then you have delta t. So the derivative would be f of t plus delta t minus f of t, the change over the time. When you see d divided by dt, d of dt, then this is an operator. Think of it as a plus or a minus, d of dt. Why? The d is delta, a change. The dt is the change over time, and this is exactly what we are measuring. This is the operator. So if you have a function of t and you apply this operator, d divided by dt, this means that you measure the change d over d of t, the change over time. So the d over dt operator is the change d over the change over time, dt. It's just an operator that you apply to functions. We said that the integrals are the measurements of the accumulation over time. And indeed, if you look at a chart of y and x and you see some graph, then the integrals would be the area under the curve. And as it turns out, the area under the curve is a very important measurement. We denote the integral with a sign that looks like a very big S. And this is not a coincidence because we said that the integrate is measuring the accumulation and accumulation is sum. So this large S is denoting the sum that we are measuring. And when you measure a sum of something, you need to say where you start to measure the sum and where you end. So we, on the lower side of the S, we say where we start, and on the other side, we say where we end. And then inside the integral sign, we put the function that we do the sum of the values of the function. So as we said that the integral is the area under the curve, then if I look at the chart and my area looks like, let's say the y function is just 4. So for every x, I have 4 until some t. And I want to measure the integral. So it looks like a rectangle. So the integral of this function that looks like a rectangle would simply be the multiplication of the two sides. And if my function looks like x, y equals x, and I want to measure it up to 2. So again, because it looks like a rectangle, then the integral of this function would be the area of this rectangle. So in these two cases, it was very easy to measure the integral and to say what is the result because we simply see a visual image of the graph. So we can say it. And this is what calculus then deals about how to measure the integrals and the derivatives of stuff that you cannot visual immediately. So you need to do some calculations. We said that the integral and the derivatives are the inverses of one of another. And indeed, we also said that the derivative is denoted by the operator d over dt, and the integral is with the big S. So indeed, if we apply one operator over the other, if you apply the S of the integral over the d of dt, then they cancel each other. So if I have d of dt of f of t, so I know that if I have a formula that says that the derivative of f of t is g of t, and I want to know what is f of t. So I apply the integral to both sides of the equations, and since in the left side of the equations I have d of dt and I apply the integral, then I'm left with f of t. And on the right side I have the integral of g of t, which is the derivative. So I was able to do simply the undoing of the derivative by applying the integral operator over both sides of the equation. And this sums up the basics of integrals and derivatives. One is the inverse of another. We have the operator, so we have the d over dt, which is just an operator like minus or plus or whatever. This operator is the operator for the derivative. And if we apply to it the integral, then they cancel each other because they are practically the inverse. And we saw that we can calculate the integrals of functions quite easily if we can see them visually, and all the left is left to the whole of calculus. So I think this was very interesting episode.